Hey there, you're looking at something called the Morphing Clock. The original code was written by somebody named Harry. I picked this project up about 2 years ago and built the clock, and I've made a lot of changes to the source code. And recently I had to revisit the source because the weather stopped working consistently. And when I went to visit the weather service, which is called Open Weather Map, I found out they are discontinuing their API 2.5 call and going to the 3.0 call, but it also requires a credit card on file. And I decided to drop that weather service altogether and change over to a different weather service. And in the process, I decided to rewrite the entire weather logic, and it's now using 5 different weather services. So you can pick from any of the 5 that I've selected. All 5 are free, no credit cards required, and I can add more weather services down the road if necessary. I've also added logic for the nighttime mode, so if you want to dim the clock when you go to bed, there's an option for that. And there's a nice web service built into this clock for changing all the settings. You can change color palettes, you can change the date format, you can go from metric to imperial formats. And what happens every 10 seconds in the upper left corner, it switches between the wind and the humidity. So you'll see here in another second how it switches over. The humidity changes color. Right now it's 94%, so that's why it's in red. If it's lower than 80%, it's a different color. If it's around 50, it's a different color. So it changes colors, as does the temperature. If the temperature were in the 90s, that would also be red. There's options also for weather animation. If you don't want the English version, like right now it's saying partly cloudy, you can have animation graphics to use. That's a switch that's also available in the web page. So this video is going to go through the entire Arduino process, installing the IDE, which is the compiler, downloading the source code from GitHub, and I'm going to go through all of the details on building and installing libraries, making some minor changes to the NTP clock if you live in the United States, and any other changes that are required to get this code to compile. So hopefully my goal was to make this video easy enough that even if you're not familiar with Arduino, I think you could get through this fairly easily at building this clock. Because building this clock is very simple. It virtually requires no soldering. It's just a bunch of cabling that you run in the back, and my hardware build video will go through that part. But this part is strictly software. So let's get started. So the first step we want to do is download the source code from GitHub. And the location is github.com/gquerying/morphingclockq. This is the page you'll see. Don't try to download all these individual files. That's way too cumbersome. Just go to the green button and download the zip file. Once you have the zip file, wherever that downloaded to, bring up your folder or file manager, whatever you use for the operating system. And in this case, for some reason, GitHub does something a little unusual. They put a -main on the zip file, and also in the zip file they call it -main. So when you unzip this folder of all the source code and the .h's and everything, you want to get rid of the -main, because otherwise the IDE, which is the compiler, will get confused with the -main on it. So just rename it to Morphing Clock Q with no -main. Alright, so once you've done that, the next step is to go to the software IDE, which is arduino.cc, the language you're in, and software. And then you're going to download your version of IDE. Now it could be Windows, it could be Linux, it could be Mac. Pick your installer and download it. Once you've downloaded the install program, run it. pick all the defaults. Don't worry about anything. Just take everything as a factory default. All right, so once you've installed and launched the IDE for the Adrenio, the first step you want to do is go to the File menu, Open, and open the GitHub zip file that you downloaded, that you renamed and took the -main off of. So wherever you downloaded that to, or wherever you unzipped the file to, navigate here to that and open it. And this is what you should see. You should see something that looks just like this. So scroll down a bit, and obviously the line numbers will change as the source code changes. So this video is being made right now on May 16th. It's possible you'll be looking at this video later on and the line numbers will change because it'll have more information in it. So I can't go by the line number. But scroll down and you'll find a section in here called Preferences Menu. All right. You want to take this link and go to the Edit, Copy. You want to copy that to the buffer. Okay. So now we're going to go back to the File menu on the IDE. We go to Preferences, and this is already installed on my computer, but what you want to do is you want to paste that link into your IDE. Once that's done, then you want to go over to the Tools menu. You want to go to the Board Manager, and over here you want to type in ESP8266. We have to install this. This is not by default installed. This is going to manage that 8266 board. Now this is critical and you have to listen closely because this is the most common mistake I found on my prior video where people miss this step. When you install this, the default is 3.1.2 or possibly even a later version. That won't work. Using that little down tick mark here, you want to pick version 2.7.4. Do not install any of the 3.0s or the 3.1s. That will not work. This code does not compile. There's some libraries relating to the display that are not modernized. They're old code and they won't compile. So you have to pick the 2.7.4 and install that version of the board. All right, so now you have to select the board. So you go to the Tools menu, and here under Board, this won't show yet because you haven't selected it. You want to go down to ESP8266. I found this board generically works with just about everything. So you can try this one. If that doesn't work, just try some other ones. Try the generic modules. But overall, this Node MCU 1.0 seems to work really well with the 12E on it. Once you have that selected, then you have to deal with the COM port. The COM port is kind of fussy. Windows 11 can be particular. I'm not going to get into it, but with the details, sometimes you'll need to downgrade the COM port driver that's required to get this board for the computer to see it. I did put a link in the source code for the driver where you can find an older driver for Windows 11, so you can try that. But hopefully you won't have that issue. But if you do, look inside the source code. I'll mention where you can get the driver link for it. Once you've got the COM port shown, you want to go to the flash size. Pick this one. I found the first one doesn't work anymore. The 4 meg, FS, 1 meg, OTA, 1019 KB, this works fine. So pick that flash size. For the first time compiling, I also recommend erase flash, set it to all flash contents. This is also critical if you've already installed the Morphing Clock code on your ESP. Things change at times, and it's important to erase the entire ESP module. So make sure you pick all flash contents. Now that we've set up the IDE, now we need to download a bunch of libraries to make this code compile. The program has quite a few libraries to install. And again, in the INO, if you scroll around, you'll see here where I'm going through what libraries you need. So from the library manager, you can install these libraries, but I highly recommend you don't go that route. I've made it easy. I've made a Google Drive zip file right here. You can copy paste that into a browser tab and then download this zip file. That will contain all of the proper libraries you need without having to manage and install them manually. If you want to install them manually, you would click this little icon here, or you can go to the Tools menu and you can go to the Library Manager, which is over here, and then you can start searching for which library you want to install. So these are the versions that are known to work. It could be, again, when you're watching this video, it could be a year or two down the road, the version numbers might change. It may not work with future versions. So if you pick these versions, it's going to work. But again, I would just grab the Google Drive link. It's a lot easier than manually searching for these libraries. Okay, so once you've installed all of the libraries, you've got another important change to make. If you're in the United States, the NTP clock, which is what gets the time from the internet, is defaulting to European. So you have to edit this file, which is in your library directory. Your library directory is based on where you installed the IDE. But under the library directory, there's an NTP client source, NTP client lib.h. That's the file you're going to have to edit. You look for this line here inside the source code and change it to this setting here. It's set to EU. Obviously, daylight savings time is different in Europe versus the United States. So that's very critical. If you live in the United States, you'll have to manually make that change to this document here. The next step is to copy the params edit this first .h to params.h. This file contains all of the special settings for the clock. I'm going to show you the params edit this first.h file. I can't show you the params.h because that's got all my password information in it. So params to edit.first, which you're going to copy to params.h. You have to set up at a minimum your SSID and password. You're going to change these settings between the double quotes. Do not put anything here between the braces. You do all your changes between the double quotes. So whatever your SSID is, it could be, Gary's house. Whatever your SSID is, put that in there. And whatever your password is, 1, 2, 3, 4, 5, whatever, put your password in there. These two have to be set up for the clock to work. It's a DHCP only type of connection for your Wi-Fi. It's not using a fixed IP. The rest of the settings, you don't have to do it right now. This clock code comes with a built-in web server, and the rest of these settings can be done on the web. So if you don't want to deal with that right now, you don't have to. But if you want, and you want to see the clock work on the first shot, you're going to have to give it some more information. Time zone is based on your location. Use Google, figure out where you live and what the time zone is. It's an integer value, usually something of a negative number or a positive number. Military is the time format, 24-hour, 12 hours. If you want 12-hour format, put a no. If you want 24-hour format, put a yes in there. The date format It defaults to month, day, year. If you want a different date format, you can pick from these settings here and change it inside the double quotes. Daylight savings time, if you're living in an area where that changes, set that to true. If not, set it to false. Color palette, I would change that on the web. The web interface will tell you more about the color palette and what's available. The brightness will max out at 70, so even if you key in over 70, it won't go over 70. 70 is what they recommend for the driver. Nighttime start, nighttime end is a new feature. This allows you to dim the clock when you go to bed. So if you want, let's say you want to, at 11 p.m., set the clock to go to dim. You would key in 23. Now, if you notice, I said 11 p.m., but 23. It's easier in the logic if we talk military time for this feature. So you can still have your military time set to no for 12-hour format, but the dimming for the nighttime mode is in 24-hour format. So just key in the numbers in 24. So at 11 p.m., it's going to go to dim, and then maybe at 7 a.m., it's going to come back to full brightness. And again, if you don't want this feature, set both of these values to 0. The weather service, I set up a PDF file. It's called weather.pdf. You can get more details in there than what's in this file here. I highly recommend you start with this OpenMedio, which is option 4. This service is really nice. It's simple. No setup required. You don't need to set up an account. You don't need an API key. You just plug in the number 4 into the weather service, which is done down here. It's already defaulting to 4, and you will get weather. Provided, obviously, you have to give it your location. All the weather services need to know where you are. So all of the weather services support latitude and longitude. Some of them support the zip or postal code. But if you want it to work on the first shot, use a web service, find out your latitude and longitude, and plug it in between the double quotes. If you want the postal code to work, you must not have a latitude and longitude set up. The program can't use both. It will override if you have both set up to use the latitude and longitude. So if you want to use the postal code, make sure these are null. There's nothing between the double quotes. The weather service, as I said, is 1 to 5. It defaults to 4. The other services will all require an account and an API key to be set up. If you pick Weather API, you'll need to read the weather.pdf file. That requires additional settings. These are all free services, by the way, also, with no credit card required on file. The country code, only one weather service requires that, so you can leave that null unless you use that one weather service that needs it. The weather services, you will need to set up metric. This is so that the clock will output in Fahrenheit or centigrade, for example. Also the wind, if it's in imperial format or metric format. Animation, when I first got the code, it didn't have this switch. It was always in animation mode. I don't like the animation mode, so I created what they call a text mode. The text mode tells you in English it's cloudy, it's raining, it's foggy. The animation does some sort of a pixel drawing of it. Because this is a low-res LED clock, I find the animation is kind of cryptic. I can't figure out really if it's raining or snowing, for example. The graphics just aren't good enough for that. So I recommend you leave it off to no, and then the clock will tell you in words what's going on for the weather. The W-defined field is a user-definable field. In case a weather service needs some additional information, we will use this field for that user-definable. Right now, Weather Unlocked will be using that field. They require 2 API keys, which is kind of unusual. This here is a development feature, but you can use it if you like. In my case, since I'm testing this a lot, I didn't feel like constantly plugging in different API keys when I switched back and forth between the weather services. It made it a lot easier for the program to know all my API keys. So if you want, you can, between the double quotes, put in your API key for these weather services. OpenMedio, of course, doesn't need one, so just leave it double quote, double quote. If you use this feature, this key will be ignored here. So no matter what you put in this field here, it won't use it. It's always going to use these down here. So it's up to you. This you can't change on the web page. This is a fixed thing. You would have to recompile it to get this to work. Now on the web itself, as I said, you can change all of those settings. You can change your SSID, your password, your time zone, all of this stuff. And as you can see here, the color palette gives you a little bit of a clue as to what the color palettes are. The dim mode, if in military format, start and end, I have it turned off right now. Whenever you are done entering these fields, you hit the save button. And when you hit the save button, the clock reboots. That's totally normal. It was a lot easier to just reboot the clock every time you change these settings. And that's it for the params.h file on what has to be done to make the clock work okay. So now that you've made your params.h and put in the necessary settings in there, and you've downloaded and put the libraries in the correct location, and you've possibly changed the NTP lib if you live in the United States for the USA switch, it's time to compile the code. So just make sure your ESP8286 is connected to the COM port. You can go over here to Tools, and right now mine's on COM 4. So once you've got that confirmed, you go over here to this arrow. That'll compile and upload the code. So we'll press it. It compiles the sketch over here. There's no errors, so now it's in the upload phase. It's connecting to the COM port. It found it. It's uploading the binary to the ESP. And as you can see, this is pretty fast. It's not going to take very long. Now, when the clock boots up for a few seconds, you're going to see the IP address. So take a note of that. You're going to need that IP address so you can modify the settings on the web page. So you can also, in this particular case, it already went to the serial debugger. The serial debugger is this little button over here, and it can also be toggled down here, where you can go from source code to serial debugger, this little icon down here. The serial debugger is how we test the program internally, and I left some of the debug statements in. When it connects to the web service, it's going to show you the header. So the first thing the clock does is it gets an IP address from your DHCP, then it reads the data from your weather service. This is the header coming back from the web saying it's a good get command, and then it gives some other information which doesn't mean a lot. And as long as you don't see any strange errors here, you should be fine. If the clock isn't showing the temperature or the humidity or anything like that, this might give you a clue as to what the problem is. Most likely, you've not set up your API key correctly or your location with the latitude, longitude, or the postal code. If you go over to the web, you'll be able to change parameters. If you change anything, you hit the save button. This will automatically reboot the clock. So remember, I don't think I talked about this earlier in the video. If the weather service supports zip code and latitude and longitude, and you have both set up, it's going to default to latitude and longitude. If you want to use the zip code feature, then blank out the latitude and the longitude. That's the logic if you have both of them set up, because it's not going to use both to determine your location. It's one or the other. But some of the weather services don't support the postal zip code, so you have to use the latitude and longitude. So other than that, hopefully your clock is showing the time and the weather, and you've enjoyed the project.